Hello everyone, today we'll see centroid. Centroid is a geometrical center of 2D object. So we'll try to solve a numerical based on the centroid. So the question is locate the centroid of the shaded area shown. So a complex figure is shown here. The total height of this figure is 18 meter and base is 18 meter. So we should find out the centroid for this figure. Before finding the centroid, we should know what are the standard shape present on this figure. So start with this rectangle. So as you can see, there is a big rectangle present at the bottom of this figure. After that, we will easily identify a triangle located at the top of this figure. Then we can see a triangle over here, but there is a catch. Either you can consider this as a one triangle and this as a second triangle, or we can consider this as a complete triangle. Now we'll try by using this as a complete triangle, or in second case you can consider this as a one triangle plus this as a second triangle and this as a third triangle. So in this way you can consider only three triangles to calculate the centroid: first, second, third. Or in second case we can consider this as a rectangle plus this as a triangle minus this as a complete triangle. So in this way we can proceed in this example. So we'll start with rectangle. So we'll consider this rectangle here. So this is our rectangle. So for this rectangle, the centroidal will lie at the center of this rectangle. So first we'll identify the distance. As we can see, the base is 9 plus 9, so it is 18 meter, and the height is 9 meter. Now we'll find out the locations of the centroidal axis from the reference axis. So this is your reference axis. So from this point we'll find this distance. This is equal to half of the base. So it is 18 divided by 2, and this height is equal to total height divided by 2. So it is 9 by 2. Here it is. Now we'll find out the area of this triangle. As we know, to calculate centroid, finding area, x bar and y bar are very important. That's why we'll first start with the area. Area is equal to base into height. So it is 18 into 9 meter square. X bar. Now x bar is the distance of centroidal axis from the reference axis. So this is your x bar, 18 by 2. So it is 9 meter. Y bar will be equal to this distance of reference axis from the centroidal axis. So it becomes y is equal to 9 by 2, that is equal to 4.5 meters. So I hope you understand the centroidal points for the rectangle. So height is equal to 4.5 and x bar is equal to 9 meter. The second shape in this figure is a triangle. So for this triangle, we'll first find out the basic dimension. So base of this triangle is 9 plus 9, 18 meter, and height of this triangle is 9 meter. So here is the height, and it is located away from this reference x-axis. So this distance we should consider. So again this is a 9 meter. Now we'll find out or locate the centroid for this triangle. It is somewhere here in front of this right angle. So this distance should be equal to base divided by 3, and this distance is equal to height divided by 3. So it is 9 by 3 and this is 18 by 3. Now we'll try to find out the area of this triangle. As we know, the area of triangle is half of the area of rectangle. That's why formula becomes A is equal to half base into height. Base is equal to 18 meter and height is equal to 9 meters. So by putting in this formula, we can easily calculate the area in terms of meter square. Now x bar is this distance from this point to this point. So that distance is equal to 18 by 3 plus 6 meter. In order to calculate the y bar, we should know this distance. This distance is equal to 9 by 3 plus we should consider this additional distance. So your y bar becomes 9 plus 9 by 3. So it is 12 meter. Now we'll go to the second part, and most interesting part of this calculation is a triangle present at the base. Now this is not the exact right angle that we have got, but if you split this figure from the center part, as we can see, it will split into two equal parts. So we can say that it is symmetric about the vertical axis, but it is not symmetric about the horizontal axis, right? So first we will find out the basic dimensions of this triangle. So base of this triangle is 18 meter and the height of this triangle is 9 meters. So we have marked that. Then we'll find out the x bar for this triangle. As we can see, from this distance to this distance, it is 18 meter. So half of it will be 18 by 2. Then we'll find out the y bar. Y bar will be height divided by 3. You can write this as an additional formula in your notebook. So we have got x bar 18 by 2 and y bar is equal to 9 by 3. Now we'll try to find out the area of this triangle. So this area is equal to half base into height. So base of this triangle is 9 plus 9. So it is 18 meters. So we'll write 18 and height of this triangle is 9 meter. Right. So 18 into 9 into 1 by 2. But one more thing to remember is that we should subtract this triangle from the original shape. That's why a negative sign should come here. So minus 1 by 2 into 18 into 9. Now we'll try to find out the x bar. X bar is equal to a distance from reference axis to the centroidal axis. So this is your x bar. So that value is equal to 18 by 2 divided by 9. Y bar is the distance of your x axis from the centroidal x axis. So this is the distance of the y bar. So it is 9 by 3 is equal to 3 meter. As we know, we have calculated the area, x bar and y bar for firstly for the rectangle, then for this triangle and then for this triangle. So we have the values of area, x bar and y bar for all three things. Now we can put it into our tabular format to calculate x bar and y bar. So I think that work you can do it on your own. So I will just give you the final answer. So x bar value should come 7.5 meter and y bar value should come 9 meter. I hope you understand how to find out area, x bar and y bar for any type of figure. Thank you very much.